In this video, we're going to simplify rational expressions when multiplying. And so when I'm multiplying a rational expression, I multiply across, and I want to try to reduce things whenever possible. So that means that the first step is factoring when I'm doing this. And so I want to look at each numerator and denominator and see if they are factorable. So starting with this x squared minus 16, I know that that's a difference of two squares. And so this factors to x plus 4 times x minus 4. And then for the denominator, I want it to be in standard form when I factor. So I want to think about this 9 minus x as negative x plus 9. And I always want to factor out any negatives if my leading coefficient's negative. So instead of thinking about 9 minus x or negative x plus 9, I actually want to factor this to be negative x minus 9. Okay, so I want to factor out that negative because I know that if I can factor one of the other two trinomials in the other ratio, if I get an x minus 9 as a factor, I want to be able to reduce that. So I have x squared plus x minus 90. So I'm looking for factors since a is 1, so that I have two numbers that multiply to negative 90 and add to positive 1. And so those numbers are 10 and negative 9. So x squared plus x minus 90 factors to x plus 10 times x minus 9. And finally, I want to factor my denominators similarly. So I have x squared plus 14x plus 40. So I want two numbers that multiply to 40 and add to 14. And so if I think about 10 times 4 is 40, and 10 plus 4 is 14. So x plus 10, x plus 4. So when I'm looking at something like this, I want to identify my domain before I reduce. And so my domain for this is going to be all real numbers except for the following x values. So my factor x minus 9 would be 0 if x was 9. The factor x plus 10 would be 0 if x was negative 10. And the factor x plus 4 would be 0 if x is negative 4. So I know that my domain is restricted from those values. And then I want to reduce to simplify this expression. So if I reduce, I'm thinking about dividing by the same factor in the numerator and denominator. So since I have an x minus 9 in the numerator and in the numerator of the second fraction and in the denominator of the first, it's okay for them to be in one or the other as long as I'm reducing across multiplication. So if I'm dividing the first one by x minus 9, I can also divide the second one's numerator by x minus 9. And so those will reduce out to 1. Similarly, I can reduce the x plus 4. So x plus 4 divided by itself becomes 1. And so that means that this expression simplifies to, in my numerator, I have 1 times x minus 4 times an x plus 10 over, I have a negative 1. Oh, I missed times an x plus 10. So notice that I missed that factor when I was reducing. And so they actually both have a factor of x plus 10. And so that means that this reduces to x minus 4 over a negative 1. And so I want to write that as negative x minus 4. If I really wanted to, I could distribute that, but it's better to just leave it as negative times the quantity x minus 4. So remember that when we're reducing these rational functions or rational expressions, we can reduce something from a numerator with something from the denominator, even if they come from different fractions. So the x plus 10s were in the same fraction, so I could reduce from there. I think because I was kind of looking fraction to fraction, I didn't notice them the first time around, right? But when I multiply, I'm multiplying across. So numerator times numerator, denominator times not denominator. And then I saw that I missed the x plus 10. So it's okay to reduce again after you've simplified. Either way, we will end up with that answer negative, and then the quantity x minus 4, where domain is restricted to all real numbers except for the 9, -10, and -4 that create a 0 in the denominator.